All right, here we have an equation, or a problem right here, and that states evaluate integral c of f dot product dr, where fxy equals negative y over x squared plus y squared, and x over x squared plus y squared, and c is the unit circle oriented counterclockwise. Well, how can we start this? Well, the first thing we can recognize is that you can basically parameterize it. So that could be, set a pencil right there, r of t equals, cosine of t sine of t. Well, we can find that. We can recognize that cosine of t is x and sine of t is y. So technically the full form is actually r cosine of t and r sine of t. So where did the r go? Well, we can obviously recognize that r equals 1, but why is that? Well, I'll get to that in a moment. But what we can do from r of t, the parameterization of r of t, is we can derivate it. So it's going to be r prime of t of the derivative of cosine is negative sine of t, and derivative of sine is just cosine of t. And we have to recognize that this is the same thing as dr in the original equation that we're supposed to use. So now we can go into y is r1, basically. So what we have to recognize is that this is a unit circle given by the problem. The equation of a unit circle is x squared plus y squared equals 1. Now, we can then obviously say that 1 is r. So basically, for x and y, the parameterization of x and y, it's going to be 1 cosine of t and 1 sine of t, which is just itself. So what goes then? So what we can recognize then is that if we move on to f of xy, it's going to be negative y x squared plus y squared, and x over x squared plus y squared. So since we already know that x squared plus y squared equals 1, we can basically cancel out the denominators right here, which leaves us with negative y x. And since we already know what x and y equals based on the parameterization that we did earlier, we just replace y and x with cosine and sine. So sine is obviously, or y is sine of t, so that's going to be negative sine of t. And x is cosine, so we just replace that with cosine of t. All right, and there we have f. So before we plug in the integral of f dr in the original equation, what we have to know is, what we have to basically know, is the bounds of the integral. Well, how do we find that out? Well, it's pretty simple. So if we take a look at a unit circle, basically this, it tells us that it's oriented counterclockwise. That means it's positive. If we look at a unit circle, the way we calculate it is we go opposite, counterclockwise, not clockwise. 0, 0 pi over 2 pi, 3 pi over 4, 4 pi over 4, or 2 pi. So as it moves counterclockwise, it ranges from 0, from the start, all the way to 2 pi after one full rotation. So that's the bounds that we're going to be using for the integral right here. All right, now we're ready for the equation, the final equation that we can plug in. So from integral of of f dr, we can now plug that as integral from 0 to 2 pi of, since we already know what f is, that's going to be negative sine of t. Let's put a parentheses there. Negative sine of t, comma, cosine of t, dot product, negative sine of t again, cosine of t, all over or all with dt. Now remember, this is f, and this, oh, not including dt, this is dr, and the dot product in the middle. So remember not to confuse dot product with multiplication. It's a little different than that. It's going to be 0 to pi of negative sine t times negative sine of t. That's going to be positive sine squared t plus cosine of t times cosine of t. That's going to be cosine squared t dt. Now, if you know your trig identity, sine squared t plus cosine squared t, or sine squared whatever variable plus cosine squared whatever variable, that's going to equal 1, simply. And now we're left with integral from 0 to 2 pi of 1 dt. Now, what's the integral of 1? Well, based on the variables that we have of t, that's just going to equal, I don't need the integral right there. That's just going to equal t. T from 0 to 2 pi. 2 pi for the first one, minus 0 for the second one. Our answer is 2 pi.